Okay, can someone recap for me where we left? Arnav, we were on homework. Did we discuss homework 4 fully?
I don't think so.
If I recall, there were question 7 was left. We'll come to questions. Did we discuss question 6 or someone? Precious, maybe you know, where did we leave question homework 4 with?
Sir, I'm pretty sure we were done with most of homework 4. I don't think there was anything left because we had also done the last question of homework 4, I think. I remember.
Oh, so question 7 onwards is left in homework 4.
Question 7 onwards is left. That's what I thought too. Again, there might be slight differences because of the 2 different batches. So let me just go ahead with question 7 onwards. And then if it's a repetition for some of you, just bear with me. And then from homework 5, I think it should be uniform for both. Okay, so question 7, how many positive integers less than 200 are relatively prime to either 15 or 24? Let me just paste it here.
So relatively prime means co-prime, right?
Correct. Relatively prime means co-prime. I'm not sharing my screen yet, right? Just one second, let me do that. Sorry guys, since I'm traveling, it's a bit of a different setup for me. So bear with me. Yeah, relatively prime is co-prime, Precious. Yes, correct. Okay. Manya, were you able to do this one? What did you do, or what did you?
So I didn't understand what relatively prime means.
Okay, relatively prime is like Precious was telling, right? We do not have any common factors. Co-prime is same as relatively prime. Are you able to see my screen, guys, all of you? Ranveer, welcome to the class. Are you able to hear and listen me, hear and see me well?
Yes.
On the screen as well? Okay. So I don't know, I might not have forwarded the earlier homeworks. If I have not, just go with the screen share for now. And then I'll forward the old homework to you later. Okay?
I have it.
You have it? Okay, all right. So relatively prime is same as co-prime. So co-prime is another word for relatively prime. And what is co-prime? Co-prime is relatively prime, right? So they do not have any common factors other than 1, of course, right? So the numbers themselves need not be prime. For example, I can give 2 numbers, 8 and 15. Neither 8 nor 15 is prime in itself, but they are co-prime because they don't have any common factors other than obviously 1, right? And by that logic, any 2 consecutive numbers will be co-prime. If you take, for example, 99 and 100, there's obviously no way they can have a common factor other than 1, right? Any 2 consecutive numbers are definitely co-prime. That is just an observation, but definition of co-prime is 2 numbers which do not have a common factor rather than 1. Is that clear? Panya, you with me?
Yes, sir.
Okay, so while we are discussing co-prime, there's also something called twin prime. Ranveer, do you know what twin primes are, if you happen to have heard this word?
No.
Okay. Arnav, do you know what primes are?
Sir, I've heard the word, but I forgot.
Okay, anyone? Sukrit? Well, why is the camera still off? Sukrit, Arsh, Akshar, Rachit.
My camera.
Is it just me or I'm seeing audio?
Sir,
It is on, is it?
Yes, sir.
Sir, I think my father sent a message about my camera.
Okay. All right. Yes, sir. Go ahead, please. Yeah.
I think twin primes are two consecutive prime numbers. I think with the difference is 2.
Correct. 2 consecutive prime numbers with the difference of 2, which essentially means 2 consecutive odd numbers that are prime. Because if you leave the number
Sir, I
2,
thought twin prime meant like two consecutive prime numbers with only one composite number in the middle, not necessarily like between them. Like for 3 and 5, it's 4.
yeah. So
Yeah.
anyway, if you leave 2, after that every even number is going to be composite anyway. So the only way a twin prime with only one composite number in between is when there are 2 odd numbers with an even number in between, the 2 odd numbers being prime. Yeah, your thought is right, but effectively it means the same as what Jan was saying, right? So just to recap again, so twin primes are 2 two primes with a difference of 2, right? Two successive prime. I don't have to say successive primes. Obviously, the difference would be 2, right? So, like I said, right, if the difference is 2, then the only possibility is there are two odd numbers with an even number in between. So, example, the very first twin prime would be 3 and 5. So, initially there are a lot of them, right? Because there are few composite numbers, there are more prime numbers. But as you go along, there are few and far between. For example, in the 90s, there is no twin prime at all. After 89, the next prime number itself is 97, right? So I think if I recall, 71, 73 might be the last twin prime less than 100. Does anyone recall anything beyond this? No, I don't.
So are there infinite number of twin primes also?
Sorry, say that again.
Are there infinite number of twin primes also?
Good question. Infinite number of twin primes also. Yes, the prime numbers themselves get very infrequent as you go. Very infrequent as in it's not so infrequent. I mean, there is some approximation, I forgot. The fraction of numbers which are prime, which are less than n, approaches some 1 by e or something. No, I'm sorry, I don't want to make it up in a wrong way. To answer your question, yes, there are infinite prime numbers and there are infinite twin primes also, but the proportion becomes very, very small compared to n itself. If you look at n, if you look at the first 100, there are roughly around 25 primes, right? Which is 1/4 of the numbers less than 100 is prime. But if you look at the first 1 million numbers, the fraction will be much smaller than 1/4, which are primes. Yeah, Prashant, you had a question? Or
Yes,
hand was up from
yes, sir. I had a question. So, so sir, I find that I'm able to solve most, like some of the questions, but so the problem is I'm not able to solve any of them under 5 minutes even, because in the real exam, I don't think we'll have more than 2 minutes. And sir, I find that I'm able to solve them, but not under 5 minutes. So, sir, is there any way we can go faster? Is there any technique?
Good question. Unfortunately, there's not. You just have to be thorough with the concepts and you have to do your mental speed, right? So, unfortunately, there's no shortcut, Precious. I'm glad you're asking a very honest question. And also, you're not aiming for 100%, right? Say there are 25 questions in 40 minutes in AMC8. You're not aiming for full 25. That'll be great, but you don't have to. Just aim for 20. That itself is an extremely good score, I would say. A good score would be somewhere in the range of 17 to 20. I'm not saying 25 is not achievable at all. Not achievable at all. But I'm saying if you're struggling with speed, set the bar too high, you have to finish the entire 25 questions. Set the bar as 20 questions, 40 minutes. You go very, very fast initially. You all know that the initial few questions are very easy. So the problem is if you end up wasting 2 minutes on the first few problems, 2 minutes per question, that's a waste of time. You should, the first few problems, you should go 30 seconds or even 15 seconds, or so that the later questions after 11, you can dedicate maybe 2 minutes, and maybe the final questions starting from 17, 18 onwards, maybe you can afford to spend 3 or 4 minutes also. Okay, all right, let's move on. So back to this question. Sorry, Precious, did I answer your question?
Yes, sir. And so just one more thing. Also, so most of the geometry questions, where they give us a figure and then they ask us the area or the height or whatever. So for most of the time, so there's so much in geometry, so that it takes time for it to strike you oh yes, we have to go about it this way, because most of the time we'll just go one way and then later you'll realize.
Most of the common geometry concepts have already been covered, right? I would suggest go ahead, recap the first few videos, right? And the first few classes were focused on geometry. There are only a few finite set of things you need to know with triangles, quadrilaterals, and circles. If you are thorough with those, that should be good enough for almost every single problem in AMC8. And for example, tricks 30, 60, 90, tricks like knowing your Pythagorean triplet quickly. For example, two sides are 20 and 21. Automatically, the third side should be 29, right? So let's say this is 20 and this is 21. 20, 21, and 29 is a triplet. You can save some time rather than doing 21 square plus 20 square and doing a root. If it's instantaneous, there comes a saving of 10 seconds, right? Essentially, all of the saving is going to come in small 10-second lots. With every single step, you have to think fast and do fast. Yeah. Okay. All right. So let's move on. Yeah, Jan, we're able to do this one. How many positive numbers are relatively prime to either 15 or 24?
So I do not know any formula. So I calculated every number. I got 96.
You calculated every, that's a lot of patience. 96.
Yes.
Okay. All right. So what about you? What did you get? Able to do this, Sukrit?
Sir, I just counted all. I couldn't do it, so I counted all of them and I got 108.
Okay, looks like both of you counted all. Then I don't know where the discrepancy still is. Any other answers, Snigdha? I thought you're not attending to your
I
traveling or
got
something.
134.
154.
134.
I got 138.
134. Okay.
Sir, I got
138.
84.
80?
84.
84 Akshaj. Okay. Okay. All right. So variety of answers. So let's discuss,
I
right?
got 55.
55.
So I had a question. How can they have more than 100 more than 100 numbers, because like half of them will be divisible by 2 and 24 is also as 2 as a factor. So how did you get that as an answer?
Exactly, right? One of my first observations is going to be, right? Even if you take a relatively prime to 24, forget even 15, right? Relatively prime to 24 means what? If it's divisible by 2 or 3, so in fact, let's start with that, right? What is the prime factorization of 24? 2 cubed into 3 power 1, right? 2 cubed into 3 power 1. So effectively, 2 and 3 are the prime factors, 24. For 15, it's 3 into 5. So now Harsh makes a very good observation. He says any number that's divisible by 2 is not relatively prime to 24, right? If a number is divisible by 2, it shares a common factor with 24. So and every even number is divisible by 2 by definition. So he's saying 100 numbers are ruled out straight away there, right? But Harsh, the question is relatively prime to either 24 or 15. So 100 does not get ruled out, right?
Oh, like that way, yeah. Oh.
Yeah, okay. But you have a good point. Okay, so how do we do this? So in set theory, I think we discussed this briefly, right? So do you guys remember this? The number of elements in A, if I count the number of elements in A union B, right, is number of elements in A plus the number of elements in B minus the number of elements in the common A intersection B. This most of you should know, right? I mean, I think we discussed this. So if I have two sets here, let's say this is set A and this is set B. Okay, so if I color all of these regions, let's say this color is P and this color is
Sir,
no, not color. I mean, if I mark. Sorry, I'll just repeat again once more, right? Let's say this is a set. Set is a collection of objects. The objects could be numbers, could be elements, could be anything, right? So if I have, and then there's some overlap. Okay, so typical, I think we discussed sets briefly at least. So a typical example would be A is a set of students who are taking maths, B is a set of students who are taking physics, right? And some of the students might take both math and physics. That's the overlap region, which is Q here. So each of these regions has a meaning, right? So P is the people who are taking just maths, right? Q is, let's say, A is A for math and B for physics. R is the number of elements that are taking only physics, and Q is the people who are taking both. Number of students are taking both, right? So by this logic, the number of elements in A would be P plus Q. Okay, and the sorry, I didn't write it well. Number of elements in A would be P plus Q. N stands for the number of elements. Number of elements in B would be R plus Q. Okay, and if I ask how many elements are there in the union of A and B, union means either A or B. right? Now from the diagram, we can say it's P plus Q plus R, right? That's the whole collection, which is there either in A or in B or in the common area, doesn't matter. So that's P plus Q plus R. But how can I generate my P plus Q plus R? It's nothing but P plus Q plus R plus Q minus R is getting, Q is getting double counted. I'll subtract Q. And that's where this formula comes from. P plus Q is the number of elements in A. R plus Q is the number of elements in B. So this is this. This is this. And the subtraction that's done is the common one, right? Whatever is common is getting double counted. Therefore, we subtract. So the number of elements in A intersection B needs to be subtracted. Vishwita, is this clear to you? Set theory, the basic number of questions, right? You know this formula, right? A plus B minus A intersection B, or you're seeing this for the first time? Did we discuss in class, guys? I mean, general question. Did we not discuss this one before? Or do you remember discussing this?
So we didn't do this.
So we didn't do this.
We didn't do. Okay.
No, we didn't do.
Fine. Is this intuitively obvious now? Now that we are discussing this, Harsh?
Yes, sir. It's very simple.
Yeah. So this is number of elements in A union B. Now we can extend this either to 15 or 24. Okay. In fact, we don't even need to extend. We can do this, apply this as it is. So the number of elements that are relatively prime. So we can just apply the same logic to this problem, right? So the number of elements, elements relatively sorry, I could not hear. What is the question? Are you able to hear Snigdha's question? Is it just me or?
So we can't hear it.
No, sir, her voice was cracking even from.
Okay. Elements relatively prime to 15. Let's call that set A. Okay. Similarly, elements relatively prime to 24. Let's call it set B. Okay. So what we want? So we want exactly. I'll stop writing n of and all that. We want the number of elements in A, number of elements in B minus number of elements in A intersection B. Okay. All right. So now that I've described how to do this question, I'll park this question here. Let's move on to other questions. We'll come back to the same question after you guys have attempted using this next time, right? I'll stop the discussion of this question here itself, and then we'll move on, and then you guys go and practice this and come back next week, and then we'll discuss this exact same question. Okay. So you can apply this. I've given you the formula. Now, just FYI, you should also know what happens if there are three elements. It's A, B, and C. Three sets A, B, and C. So if there is set A, set B, and set C, then there are multiple overlaps here, right? So if I label these portions as A, this is B, and this is C. In fact, I'll call this is set A, this is set B, and this is set C. Okay, so there are these regions. There are regions which are in between these two. Let's say this is D, this is E, and this is F. And then there's a region which is of the core, which is common to all. Let's say this is G. Okay, so here also you have a formula for the number of elements of A union B union C. Right? The number of elements in A union B union C would be A plus B plus C. Again, I'm writing it shorthand. You cannot add sets. It's meaningless to say set A plus set B. What I mean is the number of elements. Number of elements in set A plus number of elements in set B plus number of elements in set C minus all the pairwise combinations. A intersection B plus B intersection C plus only what is common between all three, A intersection B intersection C. So it will alternate between plus and minus. Individually you add them, and then pairwise you subtract them, and then triple, whichever is common for all three, that you add it back. And you can see where this formula comes from if you meticulously work out. For example, what will A correspond to? A corresponds to all the elements in A, right? Which will be a combination of A plus D plus G plus F. Similarly, B would correspond to the number of elements in B, right? I'll just write out just for clarity. So B would be B plus D plus G plus E. So like this, and similarly, let me write out one or two more. So if I have B intersection C, the common area between B and C would be this region here, right? G and E, G plus E, right? And then A intersection B intersection C would be the very core or the very center, which is just G. So like this, we write out expressions for all of these. You will see that A plus B plus C plus D plus E plus F plus G, which is the sum of all the 7 regions, would actually turn out to be, if you can just compare your right hand side and left hand side, if you simplify, it will match. So you can find out the number of elements in A union B union C. So this is also a very useful formula when you have 3 sets and you want to talk about any unions or any intersections. Some portion might be given, some other portion might not be given. It helps you figure out what is missing.
Yes.
Yeah. Arjun, were you asking a question earlier, or was it just Snigdha was asking?
No, sir, I was just saying you was clear with what you said earlier.
Cool. Okay, all right. So let's move on to question. I remember discussing question 8, did we not? What is the 2015?
We had done 8 and 9.
We had done 8 or 9, yeah.
Okay.
So question 10, 11, and 12 are remaining. So paper
Okay.
4 and paper
Right.
5.
Okay.
Yeah.
Okay, cool. Thanks, guys. So question 10. How many 3-digit numbers are made up of 3 distinct digits? Arjun, what did you get on this one?
1 second.
Have you working study, guys, all of you? Or whoever has it, Rachit, do you have it? What did you get on this one, Rachit?
So
I cannot hear Rachit. Yeah, Jan, hand it up.
So
Yeah,
810.
right.
I got
810, Arjun.
648.
So 828.
648 Akshar.
648.
The 648.
1 second.
648.
So 948. So 6.
So 648 Akshar.
So
Okay.
648 hours.
Okay, Arsh.
Yeah,
Okay,
that would be 9 into 9 into 8.
So 648. So 9 into 9 into 8. Yeah.
Is this sorry?
okay. Multiple of you 648. Okay, we'll discuss some other variants also. Yeah, that
Sir,
is easy.
I'm getting 6.
Sir, I got 504.
Yes, sir. Even I got
So
500.
828. Sir, I got 828.
It should be
828.
648.
Sir, I
648.
got 720.
Okay, all right. I'm
The six-
losing track of who got what, but I've listed out all the possible answers. Let's quickly discuss.
But even
How many
648.
3-digit numbers? Okay, 3-digit numbers means obviously it goes without saying cannot start with 0. Cannot explicitly say that. Are made of 3 distinct digits. So first digit, second digit, third digit. Okay, so first digit, I can put any digit from 1 to 9. I cannot put 0. I can put any number from 1 to 9. So 9 possibilities.
wait. So, sir, sir, I forgot to say my answer, sir. I got this. What do we say? 567. 567.
So I actually miscalculated. Mine is 729 and not 828. I miscalculated.
All right.
And sir,
I'm
567.
just amazed how there are so many answers. 567. Okay, it looks like the number of answers would exceed the answer itself, right? There are only 1,000 numbers, of which there are only how many 3-digit numbers? 900 3-digit numbers. Okay, thankfully none of the answers is more than 900. Okay, all right. What are we doing? So first digit can be occupied by any of the 9 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9. The second digit can be any digit other than the first digit. For example, I'll just put an example here. Let's say the
Yes, sir,
example
and-
digit is 2.
Sir, and the main part
In
is
fact,
that
I'll-
you can use 0 on the second digit.
Exactly, right? I'll put the number here, example here, and I'll put the count here below this. So 9 possibilities for the first digit. The second digit, as Arjun was saying, can be any number other than 2. So let's intentionally put 0, right? So there are 9 possibilities, right, for the second digit. It can be any digit other than the first digit. And the third digit can be any.
Oh, so sir, I miscalculated.
which is 81 to 8, which is indeed 648, which multiple of you got. I'm sorry if I missed some names, but I remember many people called out 648. Thankfully, at least that was the majority. But I can understand 810 as an answer, because you would have done 9 into 10, 9 into 9 into 10, was it? What did he do to arrive at 9?
Sir, I did 9 into 9, sir. 9 into 9 into 10, sir.
What is the
Sir,
logic?
I made a small mistake at first, sir. I understood before he explained.
Okay, all right.
And so I'm multiplying by 8 as the last, and I did 7 for some reason. I do not know why. I did 9 minus 2, and I didn't like think about 10. So
Okay, all right. That's fine. So let's discuss some few variants of this question. Okay. So first variant, how many 3-digit numbers are made up of 3 distinct? In fact, I'll remove the word distinct. So first, let's do this simple variant. I'll erase the word distinct. How many 3-digit numbers are made up of? In fact, yeah. Okay. All right. I'll stop here. What is the answer to this question, guys?
900.
900.
900.
Exactly. It's like asking how many 3-digit numbers there are, which is 900, right? Which anyway, you can still do it by hand like this also. The first digit can be any of the 9 digits from 1 to 10. 1 to 9, I'm sorry. Second digit can be any of the 10 digits. Third digit can be any of the 10 digits, which is how you got 900. Okay. All right. So let's put back the distinct digits now. And I'll say how many 3-digit numbers are made up of 3 distinct digits with
Static question.
all,
It
yeah,
sounds so weird. Like only there are 999 3-digit numbers, and only like
no, 900
900 can be made out of 3 digits. What
there
about
are
the
900,
99?
there are 900 3-digit numbers, not 999. 100 to 999.
Oh, yeah.
Yeah, 100 to 999. The difference is
So
899.
24.
The counter. Okay, okay. All right. Someone has already answered this question. All digits 24. Huh? Okay. All right. Let's give some time. If was the first answer. Sorry, who was that? Can you all name as well? Sometimes the voice is a little
Ranveer.
cracking, so I
Ranveer.
not know the name. Ranveer.
Yes, sir.
Okay,
24.
Yes,
Ranveer.
sir, 24.
24. Okay. All right. So 3 distinct digits,
Yes, sir.
and all
20.
digits being 2, 3, 5, and 7. Okay. So the first digit can be any of the 4. Second digit can be any of the remaining
24.
3. Third digit. Okay. All right. Next one. With at least 1 digit being prime. Okay. So right again.
With at least 1 digit what?
3 digit, with at least 1 digit prime. So there must be at least 1 prime digit. For example, I won't accept an answer which is 869 because all the 3 digits are non-prime.
that's 324.
Sorry,
324.
324. Okay, right.
324.
No, you'll have to, I think, make different cases, right?
Okay, well, whatever. We will discuss. You call out your answer first, and then
Sir,
we'll discuss.
216.
216. Okay.
Sir, do they have to be distinct?
Yeah, I'm not changing the distinct. I'm keeping them distinct.
Okay.
So look like I've not erased the word distinct, right? They have to be distinct with at least 1 digit.
So 5, 6,
I did not erase the word distinct.
672.
Let's see that.
672.
5, 7.
Okay, Vanya first. 567, Vanya.
Yes, sir.
Vanya, 567 was it? Okay.
Yes.
And Akrit, what was the answer?
672.
672.
Sir, I'm changing my answer 288.
Sir, ours
288.
256.
Sir, can I have just a minute, sir?
256.
I'm getting
256.
356. Oh, wait, no. Sorry. 456.
Sir, I'm getting 412.
Okay, we have quite a number of answers, right? So let's discuss. Okay, with at least 1 prime digit. Okay, now multiple ways to do this. Okay, so since there are only 3 digits, it'll be just easy to do with 1 prime digit, 2 prime digits, and 3 prime digits as 3 different cases. Alternatively, we can do, okay, I'll discuss the alternative later, but first let's do the straightforward way. It's not too long because there are only 3 cases, right? Exactly 1 prime.
It will be 325 by mistake said 567, 324.
324 as well. Okay, all right, it's fine guys, I'm losing track of who said what. It's fine, I've listed out all the answers. Okay, exactly 1 prime digit. Okay. So exactly 1. First of all, how many primes are there? So there's 2, 3, 5, 7, and everything else is non-prime. So that way 0 is also non-prime, 1 is also non-prime, but by the way 0, 1 are neither prime nor composite, but they are anyway non-prime. That's all. Right now I have only two categories, either prime or non-prime. So non-primes are 1, 0, 1, 4, what am I missing? 6, 8, and 9. So total of 10 digits, right? 4 which are prime and 6 which are non-prime. So exactly 1 prime. Okay. So exactly 1 prime. So you have to be careful with 0 also, right? So with exactly 1 prime, exactly 2, okay fine, we'll do exactly 2 primes and exactly 3 primes, those 2 cases, right? With exactly 1 prime, okay, first let's keep it simple. Let's take with 0 and without 0, with 0 and without 0. Okay, suppose with 0, what do you mean by with 0? You have chosen the digit which is 0 already, so we need to, so this 0 is already a non-prime number. Now we need one more prime number and one more non-prime number, correct? We need to select one more prime number and one more non-prime number, because 0 is already selected. So I'm discussing this left branch now. So I'm first selecting which are the digits. So the digits I've chosen are 0 is 1. Now I'll have to select one of the prime digits. I have 4 choices of selecting the prime digits, because it could be 2, 3, 5, or 7. And then I have 5 choices of selecting the other non-prime digit, because 0 is already selected. I'm selecting one more non-prime number, which are 5 possibilities. So in 20 ways I can choose the number. For example, I've picked up 0, 3, and 8, let's say, right? So the digits I've picked are 0, 3, and 8. This is an example, right? This is an example. I've chosen 0, 3, and 8. Now I'll have to form a 3-digit number. How many 3-digit numbers can I form? Assuming 0 can be in the starting position, there can be 6. But 0 cannot be in the starting position. Therefore, I can make only 4 of them, right? Either 308, 380, 803, 830. So there are only 4 ways of arranging these chosen digits. All of you with me? Ranbir, are you with me? How I'm choosing in 20 ways, and having chosen, I can arrange them in 4 ways, right? So this is 20 into 4, which has 80 numbers. In fact, let me put it in another color. I'll write it as a product of, so this is 4 into 5, which is 20. I'll write this as 20 into 4. The 4 is the ways in which you can arrange them, right? So 20 into 4, which is 80. Okay. Without 0. Without 0 is the other part.
4.
20 ways of choosing what digits we want. Since I and 0 is non-prime, my job now to select more non-prime digit and prime digit. Correct? That's why we are at 4 into 5. Does it make sense, Harsh?
So your voice is cracking a lot for me. That's why I can't understand.
Oh, okay. Could be my. Okay, sorry. Is it better? I'm traveling. I'm on hotspot. Please call out if it's not very. Is it clear? Slightly better now, Harsh?
Yes, sir. Yes, sir.
Okay. So did you understand how I arrived at the 20? 4 into 5 equal to 20.
Yes, so that I got, and then after that, yeah.
After that, I have to arrange 0, 3 and 8, correct? So 0, 3 and 8, three numbers can be normally arranged in 3 factorial, which is 6 ways. But the number cannot start with 0.
Zero.
So I'll subtract off the two numbers which start with 0. So it's
Yeah.
only 4 numbers using 0, 3 and 8.
Yes.
Yeah. Okay. Now, when we do without 0, it's easier actually. Without 0, I don't have this headache of, right? Without 0, what is my job? My job is 0 anyway is not in the picture. I'll have to select 2 non-prime digits, which can be done in 5 choose 2 ways, right? And I'll have to select 1 prime digit, which can be done in 4 ways. 4 choose 1, which is same as 4, right? Because there are 5 non-prime digits other than 0. There are 5 of them, 1, 4, 6, 8, 9. Among them, I can select any 2. So 5 choose 2, which is 10 ways into 4. In 40 ways, I can choose 3 digits. Example, I'll put an example here. Let's say the non-prime numbers chosen are 1 and 8, and the prime number that's chosen is 5. This is an example, right?
So, but
Having chosen,
multiplying by 4.
sorry,
Here, why are we multiplying by 4 here? Like, it's 3 factorial. Isn't it?
correct. Here we have to multiply by 6. So 40 into 6. 40 is the number of ways of choosing. Now comes the arranging ke liye, I have to multiply this number 40 by 6. Is that what you meant, Akrit?
Yeah.
40 into 6. So 40 into 6.
So I thought
Okay.
we put that into 4 down as the like final thing.
Oh, no. This 4 is choosing one of the 4 prime number. 4 choose 1. Right? So
Yeah.
4 ways of choosing the prime digit, that's 4. So I have chosen in 40 ways. Now having chosen, I can arrange them in 6 ways. So 40 into 6. Is everyone clear with both of these cases with exactly 1 prime? Okay, exactly 1 prime is the hardest, I would say, because the other 2 should be fairly easy. Okay. All right. So now comes exactly 2 primes. Exactly, I have to make some space here. Okay, fine. I'll just make space here. Exactly 2 primes. Okay, so exactly 2 primes, which means 1 composite number and 2 prime numbers, right? So again, let's split into 2 cases, with 0 and without 0. Okay, so with 0 and without 0. So if 0 is chosen, then let me put an example with 0, then the other 2 have to be prime, right? Because 0 is already the non-prime digit, and we have to select a number with exactly 2 primes. So an example number would be 27, 027, something like this, right? In how many ways can I choose? There's no choosing for non-prime numbers at all, because 0 is the only one which I've already chosen, and then I can select any 2 ways, which is 6 ways, right? And having chosen these 6, in how many ways can I arrange them? 6 into 4, just like, exactly like 20 into 4. We'll have 6 into 4 here. So I'll just put 6 into 4. Okay, now I know that Prashast will ask, now how can we do this question in 2 minutes? I'm not expecting you to do this question in 2 minutes. For everyone, I'm telling the answer. But these could be smaller samples from this bigger question that you can use in another question, right? So obviously this is a more elaborate question which will require at least 5 minutes. Now when I'm describing it, it'll take 10 minutes maybe, but when you do it on your own, it'll take maybe 4 minutes, right? A good 4 minutes. Maybe it can be one of the 23rd, 21 plus range questions. So 6
Yes.
into 4, which is 24 ways.
And so just like
Yeah.
one more thing,
Okay.
since we brought up that whole time thing. So like also that, sir, I understand once you explain, but most of the questions I find that I'm not able to do on my own. I understand your explanation perfectly, but then I do it on my own, it doesn't happen.
It has to happen eventually, right? Which is why I suggest, in last week I put a message in the group, go back and redo all the old homeworks and the different variants that we discussed. So as you do more and more, that's when you perfect yourself, right? It's like any art. You keep doing more and more of it, you develop both your speed and your accuracy, both of them, right? There's no shortcut. Okay, all right. So without 0, again, I'll write an example here. So without 0, let's say the two non-prime digits I've picked are 4 and 9. And the prime digit, exactly two primes, right? So I have to select 2 prime. And let's say it is 3 and 2. And then the prime digit that I select is 6, right? So here again, how many ways of selecting the 2 prime digits? 4 choose 2 ways. And how many ways of selecting the non-prime? It can be any one of the remaining 5, because 0 is eliminated. So 4 choose 2 into 5, just 30 ways. 4 choose 2 is 6, 6 into 5 is 30. Now each of these 30, you can arrange them in 6 ways, right? So 30 into 6. Okay, so 30 into 6. Now the last case is very simple. I'll do it up here. Exactly 3 prime digits. Exactly 3 prime digits. Okay, so now there's no question of 0 at all. So all I have to do is select 3 prime digits and arrange them. So 4 choose 3 ways of selecting. 4 choose 3 is among 4, I'll have to select 3, which is effectively saying is among 4, you eliminate 1. So I have to select 3 prime digits, means I'll say which is the prime number which is eliminated. 4 ways. Yeah, sorry, go ahead. 4 into 6 ways of arranging them, right? Because there are 3 of them and there's no 0 at all. 4 into 6, which is 24. Snigdha, I know you said something, but I could barely hear you better. You want to repeat what you said? Snigdha? Okay, all right. So, Vanya, able to hear me well, right?
Yes, sir.
Okay, good, Vanya. Sorry, Snigdha, what were you saying? Okay. So 4 I'm sorry, guys. Can anyone else hear her well? Can you translate the question? Akal, did you hear her question? Yeah, you can type it, or maybe you have done it and I've missed it. I don't know. What is the answer to the main question? 648. That was the last thing I had. I don't have anything after that. Okay, yeah, Snigdha, type your question. So the answer to this question is the sum of all of these, right? So let's add and see how much do we get, right? So it's 80 here. It's 240 here. And then 24 here. And 180 here. And then this has only one case, which is 24. So can someone add 240, 80 is 320. 320 plus 800, 180 is 500, 524. 548. Okay, so I don't see a 548, but I didn't expect you guys to do it in such quick time anyway, right? So even if it got something, I would have thought it would have been a bit of a in the lucky side to get it so fast. Okay, but don't worry about speed and all. Is this clear, guys? The conceptually how to approach these kind of problems is clear. Permutation, combination. Rasha, is it okay with this one? This question?
I did it in a different way, and I don't really know what was wrong with my method, so can I
Okay,
just
go ahead.
tell you? Yeah, so
Can you share what you did?
I did a similar thing, except that I didn't do with 0 and without 0. So I said with exactly one prime number, you will have 5 into 5 into 4 possibilities.
One second. With exactly one prime number. So with exactly one prime number. So you're saying 5 into 5 into 4. Can you describe what your 5 into 5 into 4 is?
So there are 4 prime numbers, right? So I put them in the last, I put them separately, and then I took the other 6 that are there, but 0 cannot come in the beginning. So I put 5 and then into 5 because you've.
But you're forcing that the digits must be non-prime and the third digit must be prime in doing so.
You're cracking up.
No?
You're cracking up.
Sorry, by writing it in this way, you're forcing the first 2 digits to be non-prime and non-prime and the third digit to be prime. Right, Adi?
Okay.
Ranveer?
Okay.
But that was not necessary, right? The prime digit could have occurred first.
Oh, okay.
Yeah, makes sense?
Yeah, okay. And
Yeah. So both are important. So, yeah. But it's good that you dealt with the 0 correctly. You didn't put 6, you put 5 here. But the problem is 0 could have been the third place also, right? The prime digit could have been the first place.
Okay.
Okay.
Wait, so then
Alright.
can I multiply it by 3 factorial to like
You cannot, because again 0 cannot be in the first place. So in some cases it has to be multiplied by 4, some cases needs to be multiplied by 6. If 0 is there, then it's only 4 ways of arranging them. If 0 is not there, it's 6 ways. So there's no, you cannot say I can on an average I'll multiply by 5. वो भी नहीं चलेगा. So it's a little clumsy, which is why you have to do all this case work.
oh okay.
Alternatively, we can do one thing. We can say how many digits are made of 3 digits, 2 digit prime, right? We'll take the cases which have no digit prime at all, right? And then we can subtract from the total, right? From the total number of numbers which are 3 distinct digits, we can subtract. In fact, let's see whether we get the same answer. Or in fact, I'll leave that as an exercise. Do it and we'll discuss next class, just like what we did earlier. So I'll write it down for you here, right? So I'll say the total number of 3 digit numbers with 3 distinct digits, right? So let's say this is in fact this is what we started off by doing, right? 648 or whatever the answer was. Now we can break it into 2 parts. Okay, all non-prime digits. Okay, all non-prime digits, and then at least 1 prime digit. Now what I asked you to do was this second. What I asked you to do was this guy, which is what we broke into 3 different. We did the calculation correct. We got at 548. I didn't check if there's any. My voice is breaking for you. Okay, I'll repeat what I said. So total number of 3 digit numbers with 3 distinct digits, that we arrived at 648. That was the original question. Now we can break it into 2 categories. All the digits being non-prime, that's one category. The complement of that is what? At least 1 digit is prime, right? My question, the latter question that I asked was this guy, at least 1 digit being prime. Now this is where I split into 3 different cases and did it a long way, right? But alternatively, you can do a shorter way, which is what I am urging you to guys to do as a homework and come back. All 3 as non-prime digits. If you're able to do this guy, right, then we can subtract from 648 and arrive at the same answer here, whatever we got here, right? We should arrive at the same answer here. Is this clear, Vanya, what I suggested?
Yes, sir.
Okay, can you do that? And if it does not match, kahin to galti hai. Maybe there is a mistake somewhere. Ideally, these 3 numbers should add up, right? No, I mean, the 2 numbers should add up to the original 648. If it's not, then there's some mistake and we can find out what the mistake is also, right? So we did this the hard way. We did this guy, and added up and got an answer. You guys can do this separately and see whether these 2 add up to 648, right? If not, there is a mistake somewhere and we can figure out where the mistake is. That's also a challenge. That's also an interesting problem, right? So as we discussed in permutation combination, the multiple ways of doing a given problem, and the beauty is all of them should give the same answer. If they don't give the same answer, that means you can use it as a challenge to figure out where the mistake is. If they give a consistent answer, then you are happy that you did multiple ways and it's enforcing that multiple ways are giving the same answer. Okay, cool. That was question 10. Okay, question 11. How many prime digits exist where 2500 plus p is perfect square? Ashi, I'm not sure whether you're there from the beginning of the class. Were you able to do this one? Question 11, Ashi. Ashi Ramchadani, are you there? I cannot hear you if you're speaking something. Okay, Arsh, how about you?
I wasn't able to see. So.
Okay, any answers for this one?
No, will it
Anyone?
be number of perfect squares is infinite, number of prime numbers is infinite?
Yes,
Yeah. So Jan, you are saying infinite. Is that what you're saying?
Okay.
Yeah, sure.
Okay, Akrit is saying infinite.
So even I thought it was infinite, but like that
Okay.
could be possible.
Okay, it could be infinite. I'm not saying infinite is not. Okay, Arsh is also thinking it's infinite. Okay. Jan, yeah.
So even I said infinite.
So which
Okay.
homework is this? I'll just open
This is
it. So
this is homework 4, question 11, with the last couple of questions in homework 4.
I mean, technically speaking, it is infinite, I think. Infinite for me as well, Prashast.
Okay, all right.
Even infinite for me.
Infinite for me as well.
So same.
Okay.
Infinite for me.
It is not. Okay, all right. It is not infinite. Okay, let's discuss. So 2500 plus p should be a perfect square. Okay, so let's write it out. 2500 plus p should be a perfect square. Perfect square means what? Don't write it as x square. The reason is x is a generally used for a real number, right? A fraction or a decimal and all that. Put n or k. Generally for integers, get into the habit of putting numbers like n, k, right? A, B, C, those are all used for integers. For real numbers, which could be fractions, decimals, roots, all that, people use X, Y, and all that. It's just a question of habit. So now I want 2500 plus P should be N square, which means the number P must be N square minus 2500, which we all know is 50 square. So I'll write it as N square minus 50 square. And therefore this becomes N plus 50 times N minus 50. So P here is a sorry, Gyan, hold on 1 second. So P here is a product of two numbers, right? So if the product of two numbers, there's no way it can be prime unless one of them is in the product is 1. So 1 could be a prime number. But otherwise, if there are two normal numbers other than 1, the product will definitely be composite, right? Two distinct numbers, n plus 50 and n minus 50. So the only possibility is if this guy can be 1 and this guy happens to be a prime number, both of them should be met. When will this guy be 1? When n is 51. 51 minus 50, and 51 plus 50 in that case will become 101, which happens to be prime. So only possibility is when n is 51, which means when p is 101. So there's only one answer. Sorry, Jan, you were asking something. First you, and then after that there is one other question.
Just when you started explaining, I realized that I realized so I realized the same thing, and I was going to tell you.
Understood. Okay. All right. What is the other question? Someone else also interrupted me when
So can you repeat what you just said? Like 51?
Oh, I won't repeat. Jan, can you repeat it? Let's see whether you're able to recap for class slowly and clearly. Jan, go ahead. Try it.
Sir, I'm not sure I can do it.
No, try it. No, I always do this. It's not new to you, right? I always call on someone to explain it, so that way you also strengthen your explanation skills. Yeah, go ahead.
So, if where is the product is two numbers, so I'm not sure I'll be able to do it.
Okay. Who wants to try? Adi, you want to try explaining this to class?
I'll try. I don't know if
Okay, go ahead, please.
So we're gonna take 2500 to the other side. So it's P equal to n squared minus 2500. Then we can simplify 2500 into 50 squared, because then we get into a formula a squared minus b squared. So a squared minus b squared is equal to a plus b into a minus b, and then we just solve it.
No. In fact, till here it's fine. After this comes the core portion. Till here, I think Arsh, you understood. N plus 50 times n minus 50. Then what?
Question, sir. I have a question, sir. N plus 50 into n minus 50. That's fine, sir. N plus 50 into 101 into 1. So that's where I have a question, sir. How did that happen?
Okay.
Okay.
Yeah, go ahead, Akrit.
So if it's any other value, then it'll just be some number to some number, and p is a prime number. So that means it'll have factors. So that's why it can only be 1 into something. Because if it's 1 into something, then because it's a prime number, so prime numbers factors still are 1. So 50 plus n equals to so n minus 50 equals to 1. So n is 51. So I got till there.
I got it. So I got what you said.
So
Okay. Okay,
So
I'll repeat one more time for everyone. Okay, okay. So till here looks like everyone is clear, right? N plus 50 times n minus 50. Precious, you're clear till here?
yes.
Okay, okay. So these are two numbers which are separated by a difference of 100, but doesn't matter. They're two numbers. Now let's say this is the smaller number a, which is n minus 50. This is a bigger number b. Now, if can a prime number be product of two numbers, Precious? The definition of prime itself is that it's a number which cannot be broken down further, correct?
So
We agree.
it has to be something into one.
In fact, which is why I'm saying the smaller one has to be one, and this bigger portion should be that p itself. There's no other way.
Sir,
A
I don't get it. So what do you mean? The bigger portion has to be P. The smaller one has to be one. So that I got.
So which means the bigger one has to be b, right? Because a into b is your p. And let's call n minus 50 as the smaller portion, which
Okay.
is a.
Yes. Okay.
N plus 50 is the bigger portion, which is b. The product of a and b is the prime number p. And you yourself said that's possible only if a, the smaller portion, is 1. If a,
Yes.
the smaller portion, is anything other than 1, then I'm getting product of two numbers like, let's say 3. In fact, let's try some other number so that it's clear. Okay, let's say a is 3. Okay, let's say n is 50. So which means a is 3. A ho gaya 3, and this is 103. 103 into 3 cannot be a prime number, right? 3 and 103 themselves are prime, but doesn't matter.
So if A is 3, then N will be 47, right?
अरे
No,
क्या बात कर रहे हो यार?
57.
53.
Yeah, sorry, 53, my bad.
Yeah, 53 plus 50 is 103.
Yes.
103 into 3, can it be a prime number? No.
Acha, okay, got it.
The only way this can happen is the smaller portion is 1, right? And in that case, the bigger portion happens to be 101, right? Does it make sense?
Yeah.
Okay. I'm just thinking of another question this related to this.
There's only one prime number.
Yeah, there's only one prime number. Yes. Yeah. And suppose the question had been instead of 2500, let's say I have 1 second. I'm just taking the 100. Just 1 second. I'm just trying to make up something. 55. Yeah. So let's say it's p plus 20. Okay, I'm just trying to 1 sec. Let me just make up one question. I want to illustrate something, but I'm struggling with a good example here. 121 plus 100. Yeah, okay. So instead of p plus 2500, had the question been just p plus 100 instead of p plus 2500, had it been p plus 100. So I'll go through the same steps, right? And I'll say p equal to n square minus 10 square. And then I'll say this is n plus 10 times n minus 10, right? And again, I'll say the smaller portion has to be 1, only then it's possible. But look, if the smaller portion is 1, this portion happens to be 21, and this product is not prime, which means even that is ruled out. In such a case, even one prime number does not exist. At least in the problem that was given here in black, there was one possibility because 101 happened to be prime. But in this case, in the other example that I just made, 21 is not even prime. एक तो possibility था वो भी निकल गया हाथ से. Sorry, Bishwita is there in the class and she cannot understand Hindi. I'm sorry. There was only one possibility, and even that is gone now. 21 is not even prime here, right? At best, one was possible. Even that is gone in this example. Bishwita, is this clear to you? This example? Okay. Am I audible, guys, or am I still breaking? Because the difference between n minus 10 and n plus 10 is 20. Or rather, if n minus 10 is 1, that means n is 11, right? Panya? Therefore, n plus 10 becomes 21.
Oh, okay. Yeah.
I made up another question where, just to illustrate, even one prime number is not possible in this other example. At least in the original problem, there was one prime number that was possible. Yeah. Understood, Amanya?
Yes, sir.
Okay, Akshay, you had a question. Your hand was up briefly. Okay. Okay, next one. This is the last question in this homework, right? 2 power blah 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 blah. Okay, let's see. Akrit, what did you get on this one?
So I tried to start it, but I didn't get, because like it's not just like you kind of multiply the indices, right? Because it's like
So it's 3. It's 3. X is 3.
X is 3.
X
Okay.
is 6 according to me.
Sir, X is 6, sir.
X
I
is
got
6. Sir.
Sir, X is 6. Sir, X is 6.
Okay. 3, 6. Any other answers?
I got 40.
X is 3.
Okay, Vishwita, you had an answer. Sorry.
40.
40. Okay. Okay. So 3, 6, 40.
So even I agree with 40.
So
40.
3.
3, 6, and 40. Okay. All right. Let's discuss. Now, first, some very basic rules, right? So all of you know this, but just as recap. So if I have 3 power 4 whole power 7, that's 3 power 4 into 7, which is 3 power 28. All of us know this, right? But suppose I write this as 3 power, if I write it like this, then there are two interpretations to this. Someone might think it's 3 power 4 whole power 7. Someone else might think it's 3 power 4 power 7, right? If I don't put the bracket, which one should I interpret this as? I should interpret this as this. No, it's the latter one. If it's the first one, people would directly write it as 3 power 28 or rather 3 power 4 whole power 7. If I don't put brackets, it means it's the latter one. It means you start operating from the top and slowly start coming down. So by that logic, if I have 3 power 3 power 3, right? So it is actually 3 power 27. It is not 3 power 9. We should take this root instead. We should say 3 power 3. Therefore, it's 3 power 27, right? And the same logic happens if I have 2 power 2 power 2 power 2. So first I'll do this 2 power 2, which is 2 power 2, which is 4, and then I'll write this is 2 power 4, and then I'll do this. I'll say this is 2 power 16, as opposed to, or by your logic, you would have done 2 power 2 whole power 2 whole power 2.
Yes,
so you
sir.
would have 2 power 4 whole power 2, which is 2 power 8.
Yes, sir.
Right?
But 2 into 4 is it? How do we get 16?
2 into 4 is 8, correct? But I'm operating from the top up, right? So first, if I'll start with the original problem. So 2 power 2 power 2 power 2, I don't put any brackets at all, right? So now I'm saying I don't put any brackets. I have to operate from the top, I have to come down. So which means first I'll have to do this 2 power 2, which is 4. So I write the problem as 2 power 4. So all I've done here is replace the red portion. Okay, I'll replace the red portion with oh my god, I'm struggling with the number color also here. I'm so used to my setup at home. Now that I'm traveling, it's a little struggle. Okay, so yeah, this is clear. And now in the next step, I'm replacing this 2 power 4 as 16. That's it. This is clear to everyone. Vanya, you're clear?
Oh, so 2. Oh, yeah, I got it.
Yeah. Okay. Now let's use this for this problem. Okay. All right. Let me just paste it here rather than erase this. Okay. So what will I do here? So let me first do the left hand side. So left hand side, first I'll do, this is 2 power 2, which is 4. Do 3 power 4, which is 81. So this number on the left hand side is 2 power 81. In fact, I'll put the brackets so that it's very clear to you. So even I don't even need to put the brackets, but it's 2 power with a pause. 2 power 81 is the power. It's a huge number. 2 power 81 itself is a huge number. Any guesses how many digits 2 power 81 will have, guys? It's a separate side question. Any guess How many digits will forget 2 power 81 to 2 power the second 2 power? I'll just write out this question here. In fact, just so that it's very clear, I'll just, instead of 81, I'll just put some other number, 100. 2 power 100 has how many digits? Yeah, anyone? Approximately. How do you approach this? Anyone? Am I audible clearly, guys? Sukrit? I didn't hear much from you today at all. You're okay? 2 power 100, how many digits, Sukrit?
So that's 40.
Oh, 40. Any other answers?
50.
50. 50, okay.
Sir,
Okay, it's actually 30 digits.
like
Okay.
30.
30, yeah, it's more like 30 digits. How do you do it? So we can say, who said 30? Can you justify why 30? Someone else said 30, I said 30. Or was that just a intuitive guess?
Yeah.
Okay, all right. So we know that always aim to look for a power of 10, which is close to whatever number you are being asked. So I know 2 power 10, which is 1024, is approximately 1000, right? Right, 2 power 10 is approximately 1000, and I'm looking at 2 power 100 here. So 2 power 100 is 2 power 10 whole power 10, which is approximately 1000 power 10, which is 10 power 30, right? 10 power 30 has 2 digits, 31 digits, but it's fine. Around 30 digits is fine, right? 31 digits, whatever, right? And since it's slightly bigger, it's probably 31 digits. Precious, you had a question? I didn't hear you.
No, sir.
Oh, okay. I thought you said, okay. All right. So 2 power 81 by that same logic will have around 27 digits, right? 2 power, right? 2 power 10 whole power 8, right? Or 24 digits rather. 2 power 10, sorry. 2 power 10 whole power 8. 2 power 10 is roughly 3 digits. So if you multiply that 8 more times, it's 24 digits roughly. Okay, anyway, so the point is, it's 2 power a huge number with 24 digits. That's going to be huge number. Okay, so that's the number 2 power 81. It's not 2 power 2 whole power 81. That's easy. That's 2 power 162. The power is very small. 162 is relatively a much smaller number, but I'm talking about 2 power 81. Okay, now that's the left hand side. Now let's simplify the right hand side. So let's erase this. So right hand side is by the same logic, it's 4 power x. So it's 4 power x. So let me just convert all the 4s as 2 power 2. So it's 2 power 2 power 2 power 2 power x. Right? Now let's focus on the power portion first. So this is 2 power 2 whole power x. So this guy is 2 power 2x, just by simple multiplication, right? This 2 and x will multiply here. So this is just 4 power x. I've written 4 as 4. Here it's bottom up only, right? It's 2 power 2 first, and then that gets rise to the power x. So it's 2 power 2x, right? So what we have here is 2 power 2 whole power 2 power 2x. Okay, now by the same logic, this will be this number. This looks like 2 power a whole power b, right? Which is 2 power ab, right? So my a being the number 2 and my b being the number in the square brackets, which is 2 power 2x. So by that logic, so this number here is 2 power, the product of 2 and 2 power 2x. Okay. Now this number should match 2 power 81, which means my 2 power 81, that power must match this power, which is 2 into 2 power x. Okay. So now from here it's easy. Therefore 81 must match, what is this power? 2x plus 1. Yeah, whoever called out 40 is correct. I know Vishmita did. I know 1 or 2 others also joined with 40. So x is 80 by 2, which is 40. Very well done, guys. Vishwita and whoever else got 40. Yeah, I remember only one or two. Who else got 40?
Sir, can
Harsh,
you
was it you or
repeat
no?
the-
I'm sorry.
So
Sir, can you repeat? You did the last part.
I'll repeat. I'll repeat once. No problem. Sorry. Was there any other question? I'll repeat this. Was someone else said something? Okay. All right. Vanya, till which did you get till this portion here?
So I got till
Or
so I got till like 2 power 2 into 2 into 2 to the power 2 into 2 to the power 2x.
okay, 2 to the power 2. Okay. In fact, let me just repeat the right hand side once more quickly, right? It won't take too much time, right? I'll just repeat it once. So whoever didn't catch it fully can just pay one more attention. Whoever caught it can still listen quickly, right? So first I'll replace. So the question was 4 power x without brackets. So the first thing we should do is we should put brackets, because the question does not have brackets. The responsibility is ours to put the brackets where needed. So it's 4 power x was what the problem was given as, right? 4 power x. Now we come in and say, first thing, I'll make things clear. I'll put a bracket here. Okay. Then we'll break down the 4 into 2 power 2 everywhere. So we'll say this is 2 power 2 power. This other 4 is 2 power 2. That number 4 is raised to the power x. Okay. Now this guy is a simple 2 power a whole power b, which is 2 power ab. So we'll just say this power is 2 power 2x. Right. So now the question is now 2 power 2 whole power something. That something happens to be this 2 power 2x. And now it's again same a power some 2 power a whole power b. So it's 2 power ab. So a being 2 and b being 2 power 2x. Now this is the final power 2 into 2x. I can in fact write as 2 power.
Can you repeat that again? Like how you got 2 into 2 to the power 2x? Yes.
Okay, this guy came here. This is the power, right? The 4 power x was same as 2 power 2x.
Yes.
नीचे वाला 2 power 2 just remained this 2 power 2 here. Correct? Okay. Now what is this? Now if you observe this black portion here, it's 2 power a whole power b.
Yes. So it's like 2 power AB basically.
Exactly. A is 2 and b is 2 power 2x.
So then basically then it turns in acha, okay, got it.
Yeah. Okay, and then I'm equating with the final powers and the answer.
But I have a question. Isn't it not like 2 to the power of a isn't it 2 to the isn't it like the beginning only isn't it like this, like it's like this only, right? This one.
Yeah,
Like
the right hand side.
Yeah. So it's not like 2 to the power of AB, right? This one is.
It is not. It is given as 4 power x. The way it's initially given is still that. But the intermediate portion turned out to be, in fact, okay, so here, when I had 4 power x, what did I do? I broke 4 power x as 2 power 2 whole power x, right? This is, I didn't break it down as 2 power x. It's 2 power 2 whole power x, right? I am not saying this is 2 power x.
This
I'm
one
not
is
saying
fine,
it's this.
but in the below one.
That's exactly what I'm carrying forward here. If you agree with this, okay, if you agree with this, so this you agree, right? Okay, now I'll have to do 4 power this entire thing. So I'm doing 4 power this 2 power 2 whole power x, correct? You agree with this also? Now this 4 itself is nothing but 2 power 2. So it's 2 power 2 power this guy, 2 power 2x.
Wait, sir, I don't understand. Like,
which part? So if I break down 4 as 2 power 2, then I'll have to put a brackets around that to safeguard that, correct? That's exactly what I'm doing. When I break down 4 as 2 power 2, I'll have to enclose with the bracket.
But sir, like, how did
You
we
don't understand
jump?
which portion?
No, sir, I don't understand like how we jump from like 2 to the 2 to the 2x 2 to the
Okay.
2 to the power 2
Okay.
into 2 to the power 2x. How we jump from that to 4x is equal to 2 to the power 2x.
All right. All right. One more time. Pay attention, guys. Okay. It's not difficult. You just have to be careful. That's it. Okay. So one more time. So we want only the right hand side is confusion, right? 4 power x. Okay. Now I'll break it down into two parts. This part separately and this part separately. Okay. So I'll call this portion as P and this portion as Q. Okay. So first let me simplify what Q is. So Q is 4 power x, which is nothing but 2 power 2. The moment I write 4 as 2 power 2, I should safeguard it with the brackets, right? That's very important. I cannot just loosely write 2 power 2. So this is 2 power 2x. Do you agree with this, Precious?
Yes.
Precious, do you agree with this? Okay. Similarly, the other portion, which is P, is just a number 4, which I can just replace as 2 power 2. And I'll just safeguard it with a bracket here. Now, what I want is P power Q, which means I want 2 power 2 power 2 power 2x. This to me looks like 2 power A whole power B, which is nothing but 2 power AB, no? Agreed? Where A is, so A is my 2, my B is my 2 power 2x. Precious, do you agree with this as well?
Sir, sir, till here I'm fine.
Okay, all right, here you're fine, right? So fine, let's move on. So 2 power 2 into 2 power 2x. A is 2, B is 2 power 2x, which is
Okay.
which is 2 power 2 power, this is 2 power 1, this is 2 power 2x, so it's 2 power this. So by this I this way, right? 2 power, the power being 2 power 2x plus 1. You're fine with this?
Yes. No, sir. Sir, I don't understand how you did this.
Okay.
How did you get the plus 1?
Okay, this is, so till here you're okay, right? All of you are okay till here.
Yes.
Okay, now forget the bottom two. Just focus on the top portion. Just focus on this portion. This is 2 power m into 2 power n. It's 2 power m plus n. Right, Vanya? So 2 power m into 2 power n is 2 power m plus n. So 2 power 1 plus 2x or 2x plus 1.
Okay.
That guy is in the power.
Okay.
So you took,
Sorry, Vanya, you're on mute.
so you took 2 as common and did it.
I'm not taking 2 as the common base. Yeah, it's 2 power 1 into 2 power 2x, which is 2 power 2x plus 1.
Okay.
Yeah, and this is the final step, and then we compared this with 2 power. We said this guy should match 2 power 81, and we said that means this blue square and this red square must match. That means 81 must match 2x plus 1. Okay, all right. So we spent enough time on this. Yeah, definitely try it on your own, guys. Only then it will stick better. Okay, let's move on. I think I want to do, I think 1 or 2 questions at least in the homework 5. Homework 5, right? Let me just open up homework 5 on my side. Homework 5, where is it? Okay, how many did we discuss so far? We discussed 1, 2, 3, I recall. 4 also I recall doing. 5 I recall doing. 6 I recall doing. 7 I recall doing. 8.
So we did 8
Question 9 is where we have to start.
We have to do 9. Yeah.
I think we did 9.
We should do question 9. Yeah.
So we did 9.
No, we did not do 9.
No,
We didn't complete
We
9.
did it last
No,
time.
we did not do 9.
I
In fact,
remember. Sir, I
I was
remember
proposing.
someone this many awards. So मुझे अच्छे से याद है, sir. I remember us doing it.
Yes, sir. I think
We didn't complete
did
2
We
yet.
started 9, like you told us, like you gave us practice sums first.
Yeah, you didn't complete doing this. You just
Exactly.
Yeah.
I just started off this question. I said now the awards could be identical awards, or awards could be different awards, right? And then
could also
students
be
generally are
related to
different. So I wanted to do 4 different cases here. right? So the 3 students, okay, so in fact, let's not disturb the students. So the 3 distinct students, so 3 distinct students, let's say the students are A, B and C, A, B and C are the 3 students. Now there are 5 awards. Now I can make different variants of this question, right? So before discussing this question that's on the board, I want to discuss okay, so 5 awards. I'm not changing the number of awards also. 5 awards. I'm only changing whether the awards are different or awards are same. So I'll put awards here. Okay, awards are same. Awards are different. Awards are same meaning, let's say there are 5 different. What is an award? I don't even know. Let's say chocolates, right? 5 identical Twix chocolates are the awards, right? So I don't really care whether I get this one or that one because all the Twix look identical to me. That's the case of identical or same awards. And the other category I want is each student must get at least 1 per student. Okay, no restriction. Okay, so there are 4 cases I want to distribute this into. Okay, so these are the 4 cases, right? Okay, so I'll just mark these cases as case 1, case 2, case 3 and case 4. Okay, so first of all, can you guys read this original question and tell me which case does this problem correspond to? 1, 2, 3 or 4? Can you read the question and tell me which case this is?
3.
Case number 3.
Correct. Case number 3 is this original question. Correct. But before discussing this question, let's do case 1 and case 2 first, and then we will come to case 3. Okay. Case 1. Okay. The awards are all same. Okay. And at least 1 go per student. No one can go empty-handed. This is per student. How many possibilities are there, guys? Can you work out and tell me? None of everything else is same. So I'm just changing this word instead of different. Now I'm saying it's same because it's this, right? And I'm saying at least 1 per student. That restriction is still there. So these are the 2 possible phrases where I can play with, either same or different, with or without restriction. Now I'm saying with the restriction that at least 1 person, at least 1 prize for each student. So with this, how many possibilities? Anyone?
So 3.
3. Okay.
So 6.
6. Okay. 3, 6. Anything else?
Yeah, it should be 6.
Okay.
For case 1.
For case, we were discussing case 1. You're discussing case 1. Okay.
Yeah,
All right.
6.
Let's discuss case 1. 3 and 6 are the potential answers here, right? So now there are 5 awards. All the awards are looking identical. So all the 5 chocolates look identical, right? And there are 3 guys sitting here, A, B, and C. First, you give them 1 so that they are happy, right? I give this, this, and this. Doesn't matter which because all of them look identical. Now I'm left with only 2 more, right? This 2 more, either I can give them as 2, 0, and 0. Okay, and all the combinations of them, which is 0, 2, 0, 0, 0, 2, or I can give them, and unfortunately the chocolate also looks like 0. I'm sorry, guys. Okay, or I can give them as 1, 1, 0, 1, 0, 1, or 0, 1, 1. So there are 6 ways. Do you guys all agree there are 6 ways?
So is there any
Do you
formula
understand
to
that?
calculate
Yeah.
this?
Sorry.
Is there any formula to calculate this?
No formula. So for some of the simple things, just simple counting works best rather than confused with any formula. But it should be logically making sense to you. Does it make sense to you, Arsh?
Yes, sir.
Right?
Yes.
There are 6 ways. Now let's do this case. So there's 6 ways here. Let's do the case where there is no restriction. How many cases? How many possibilities? So for example, one student can get 4 awards, other student can get 0 award, and the third student can get 1 award. 401 is a possibility, or 500 is a possibility, or a 221 is also a possibility. like this, there are many more, right? So obviously it's more than 6 because there is no restriction now. How many now?
$21.
21, okay. So 21, anything else?
12.
12, okay. We'll wait for 30 more seconds, then we'll discuss.
Oh, wait, not 12, 15.
15, okay.
27.
27. Okay, let's discuss, right? We have to give out, yeah, go ahead.
I think it should be for the case 2, right? It should be
Yes, yes.
533.
Tell me a number.
1 second, let me calculate that.
So far I have 21, 15 and 27.
10.
10. 10 seems a small number, no, RD? Okay, we'll discuss. Okay, now there are 5 awards, right? So this is A, B and C. For now, just for simplicity, I will just say, I'll do the arrangement later, but for now I'll say, I'll write them in non-increasing order, as in A greater than B greater than equal to C, like greater than equal to, okay, by this, when I write, it will make sense for you, right? Either I can have, I'll start with the biggest number possible, which is 500. The next number is 410. The next number possible is 320. The next one is 311. The next one is 221. These are the only possibilities, right? My total must add up to 5, and I'm forcing myself to write the digits. Sorry?
So 302.
Go ahead.
302.
302 will get covered in the 320. I'm not done yet. So I'm forcing myself to write as A greater than equal to B greater than equal to C. Now each of them can be arranged in some number of ways. That will do as a second part now. First we wrote out with this ordering. So with 500 also 050, 005 are also possible, right? So there are 3 cases corresponding to them, right? 3 ways in which they can be arranged. 410 can be arranged in 6 ways. 320, whenever there are 3 distinct digits, they can be arranged in 6 ways. Whenever there are 2 common digits, then only 3 ways, right? 500 is like saying, where can I put the 5? Either in the A or in the B or in the C, right? Therefore only 3 ways. In this case, there are 6 ways. In this case too, there are only 3 ways. Because 311, the question is, where do I put the 3? Should I put the 3 to A, or should I put the 3 to B, or should I put the 3 to C? And similarly, 221 also, there's only 3 ways. So the total number of ways is, adding all of them, 3 plus 3, 8. How much is this, guys? 12 plus 9, which is 21. I think Vishwita answered 21. Really well done, Vishwita. Okay, so 21. Does it make sense, guys? Everyone? Okay, all right. I have a hard stop today. I have to go. Otherwise, I would have gone and discussed this question 3, which is actually the original question. Okay, but let's pick it up from here, guys. I think we are all caught up on all the backlog homeworks. We are in question 9 of homework 5. Okay, so by next class, finish up homework 6 as well. And I guess school is reopening for everyone, right, in the next few days. So make the best use of the next few days that you have to catch up on all the backlogs that you have from the beginning.
Okay, sir. Thank you.
Okay.
Thank you, sir. Bye.
Okay.
Bye, sir. Thank you.
So thank you.